Tonight, we are going back 66 million years to the very last days of the dinosaurs and the warm green world they had ruled for longer than almost anything in Earth's memory. Somewhere out in the cold dark of space, a single rock was already on its way to them, and not one creature on the planet had any idea it was coming. By the time you fall asleep tonight, you will have walked through their final morning with them, felt the sky change above their forests, and seen, slowly, how the ending of their world quietly became the beginning of ours. Somewhere beneath the ground you're lying on right now, buried under millions of years of rock and sediment and time, there are bones. Not human bones. Not anything that walked this earth in any century you could name. These bones belong to animals that ruled this planet for longer than the human mind can genuinely comprehend. Animals that breathed the same air, drank from the same water table, stood on the same continental rock that holds your city up tonight. They are gone now, completely and permanently gone, and the story of how they vanished is one of the most precise, most documented, and most astonishing things that has ever happened to a living world. It did not happen slowly, and it did not happen the way most extinctions happen, through gradual pressure, through competition, through incremental change. It happened on a specific day, at a specific moment, and the evidence of that moment is still sitting at the bottom of the Gulf of Mexico right now, buried under a mile of water and sediment, waiting. To understand what was lost, you first have to understand what was there. Close your eyes and go back. Not 100 years, not 1,000. 66 million years back to a planet that looked nothing like the one you know, and everything like it at the same time. The continents existed, just in different arrangements, pressed together in shapes no modern map would recognize. The oceans were there, filling the same basins, running the same currents. The sky was blue, rain fell, rivers moved toward the sea. Earth was Earth. Just an older version of itself, running a different operating system. There were no polar ice caps, which meant the planet held its heat the way a warm room holds it long after the fire goes out. Sea levels sat higher than they do today, and entire regions that are now dry land sat quietly beneath shallow coastal water. Forests of giant ferns and conifers spread across land masses from coast to coast. And somewhere inside those forests, flowering plants had just arrived, new, experimental, drawing the first pollinating insects toward colors that had never existed on Earth before. This world had been running, uninterrupted, for 160 million years. It had no reason to expect anything different. The opening set a slow, hypnotic tone. No tension yet. Earth 66 million years ago was warmer than today, with no polar ice caps. The Cretaceous period, a world humans never saw. Where no human had ever walked, forests of giant ferns and conifers stretched across entire continents. Flowering plants and pollinating insects had recently emerged, painting the world in new colors. The skies, seas, and land each had their own rulers. They walked where we walk, drank the same water, breathed the same air. Anchor the audience emotionally before drifting into the deep past. Therefore, what we inherit from this world is not just fossils in rock, it's the ground itself. The same tectonic plates that held those ancient forests now hold your city. The water that passed through the body of a long-necked giant eventually made its way into rivers, into rain, into you. This was not a foreign planet. It was Earth, the same one spinning beneath you right now, just wearing a different face. No ice at the poles meant sea levels that would swallow entire modern coastlines. Temperatures that would feel unbearable ran through an atmosphere our lungs could still breathe. And life, complicated, enormous, extraordinary life, moved through it without any awareness that it was living inside a clock that had already started counting down. That's the weight of this world before we begin. Not alien, familiar, and already marked. If you find your eyes getting heavy already, that is exactly what is supposed to happen. Before they close all the way, take a small moment to subscribe to the channel so the next long, quiet story is waiting for you the next time sleep is hard to find. Then let your hand rest, let the world drift, and come back to me here in the Cretaceous. But before we talk about what ended it, there is something you need to understand about the animals that were here. Because the story of their disappearance only carries its full weight when you know exactly what they were. Not as names in a textbook, not as skeletons behind glass, what they actually were, in size, in weight, in the specific, extraordinary way each one of them was built for a world that had been stable for so long it seemed permanent. One of them ate a ton of leaves every single day. One of them took 18 years just to grow into itself. And every single one of them, from the largest to the smallest, was so perfectly shaped for its world that when the world changed, none of that perfection meant anything at all. To understand what was lost, you have to understand what was there. Stand in what is now Montana or Wyoming and picture the ground as it was. Wide river valleys cutting through lowland forest, the air thick with humidity, the soil black and deep from millions of years of fallen leaves. Moving through it all were animals that no human being has ever shared a planet with. The Tyrannosaurus rex stood up to 5 meters tall and weighed more than 7 tons, moving on 2 legs through the tree line with a sense of smell so precise it could track prey from miles away through dense air. Triceratops moved in herds across the same ground, each animal weighing up to 6 tons. The 3 horns on each face worn smooth from use. The Alamosaurus was something else entirely. 20 meters long, 12 meters tall, weighing up to 30 tons. Its neck swinging slowly above the canopy as it stripped leaves from trees that nothing else could reach, eating up to a ton of vegetation every single day just to keep its body running. The Ankylosaurus moved low and slow, 4 tons of armored muscle, the heavy club at the end of its tail, capable of breaking bone. Hadrosaurs, the duck-billed dinosaurs, moved in herds along river corridors, their calls carrying across open water. And somewhere in the undergrowth, a T-Rex hatchling, no bigger than a house cat, was beginning the 18-year process of becoming the most dangerous thing on the continent. Introduce species slowly, like guided meditation through a landscape. Tyrannosaurus rex, up to 5 meters tall, weighing more than 7 tons, the apex predator of North America. Acute sense of smell, capable of detecting prey from great distances, Triceratops. Herbivores weighing up to 6 tons, widespread across what is now Canada and the western United States. Alamosaurus, the last of the sauropods, among the largest animals ever to walk the earth. 20 meters long, 12 meters tall, weighing up to 30 tons, consumed up to a ton of leaves every day. Ankylosaurus, armored herbivore, 7 meters long, weighing 4 tons, with a heavy clubbed tail. Hadrosaurs, duck-billed herbivores moving in herds across river valleys, their calls echoing through the land A baby T-Rex was only a few centimeters tall at birth. It would take 18 years to grow into the age's most fearsome predator. Therefore, what made these animals so complete, so perfectly built for their world, is exactly what made them so fragile when that world changed. The Tyrannosaurus Rex could smell a carcass from miles away, but it could not smell what was coming from space. The Alamosaurus, consuming a literal ton of leaves every single day, had built its entire existence around abundance. And abundance, once gone, leaves nothing for an animal that size to fall back on. Triceratops herds that stretched across the western plains, ankylosaurs armored against every predator on land. None of that armor meant anything against what was approaching from above. A baby T-Rex was only a few centimeters long at birth, and it would take 18 years of relentless eating and growing to become the most feared thing alive. 18 years of investment repeated across generations for millions of years, and all of it, every ounce of it, rested on a world that would soon stop being the world they had been built for. The giants got all the attention. They still do. But the animals that actually inherited this planet were not the ones ruling the ground or the sky. They were the ones pressed flat against the soil in the dark, moving only when the giants were sleeping, small enough to disappear into the root systems of the same trees the 30-ton animals were stripping bare overhead. You have never heard of most of them. They left almost no trace. But one of them, a small nocturnal possum-sized creature foraging through the undergrowth 66 million years ago, is the reason you exist, and the reason that creature survived while everything above it did not has nothing to do with strength or speed or intelligence. It has to do with something much simpler and much stranger than that. Not everything in this world was enormous. Pull back from the ground level view and look up, into the canopy, into the open sky above it, and into the shadows underneath. The Quetzalcoatlus ruled the air with a wingspan of 12 meters, the largest flying creature that has ever existed, riding thermals across entire continents on winds that never needed to work very hard because the warm atmosphere gave them everything they needed. Below it, the Microraptor moved between branches, small, feathered, covered in dark iridescent plumage that caught the light as it glided from tree to tree. Primitive birds, still learning what flight could be, tested their wings in the lower branches, and then, below all of it, beneath the root systems and the leaf litter and the soil itself, lived the animals that most people forget when they think about this period. Small mammals, possum-sized, warm-blooded, quick, pressed flat against the earth during the day, and moved only after dark, when the giants were sleeping and the forest belonged to anything small enough to disappear into it. Magma and creatures like it survived by never being seen, foraging for roots and insects in the hours the dinosaurs had no use for, building their entire lives around the gaps in a world that had no space for them in the daylight. Smaller, gentler creatures lower the energy further. Quetzalcoatlus, the largest flying creature of all time, wingspan of 12 meters, weighed over 160 kilograms. Perfectly adapted for long-distance gliding, Microraptor, small feathered glider with dark, iridescent feathers. Drifting between trees, primitive birds were just learning to fly among the branches. Beneath the forest floor lived small mammals like Magma, possum-sized, nocturnal, foraging for roots and insects only at night while the giants slept. Mammals' lives were all about being where the dinosaurs weren't. These tiny hidden creatures would inherit the Earth, though no one could have known it yet. Therefore, the smallest things alive that night were the only ones carrying any future. The Quetzalcoatlus ruled the open sky with a 12-meter wingspan, gliding on thermals over continents, and it would be gone. The Microraptor, iridescent and quick, threading between trees, gone. But the small, unremarkable mammals pressing their bodies into the soil, moving only when the giants slept, foraging in darkness for roots and insects, they stayed. Not because they were stronger, not because they were smarter. They stayed because their entire lives had already been built around disappearing. Magma and creatures like it had spent millions of years becoming invisible, becoming silent, becoming small enough to slip into gaps in the earth that no predator could follow. What looked like weakness, hiding, shrinking, scavenging, turned out to be the only strategy that worked. The creatures that owned the sky did not survive the day the sky turned against them. While all of this was happening on Earth, while the giants were feeding, and the small mammals were hiding, and the flowers were drawing their first insects, something was already moving. It had been moving for millions of years. It would keep moving for millions more, in complete silence, through a vacuum that offered no friction and no resistance, and no sign that anything unusual was happening. Nothing on Earth knew it was there. No animal looked up and saw it. No instinct fired to warn anything living that the thing approaching from space was not a shooting star, not a passing rock, but the specific fragment that had been on a collision course with this planet since long before the T-Rex existed. It carried within it the same elements that built the first living cell on Earth, and it was getting closer every year. Between Mars and Jupiter, there is a belt of rock, billions of pieces ranging from dust to objects hundreds of kilometers across, moving in roughly the same orbital path around the Sun, slowly, mostly predictably, in a kind of gravitational balance that has held for billions of years. From a distance, it might look like a single ring, like something drawn around the solar system's middle. Up close, each rock is its own object, its own history, tumbling through space on a path shaped by every collision it has ever had. 320 million kilometers from Earth, inside that belt, two of those rocks found each other. The collision was quiet by cosmic standards. No sound, no light visible from Earth. Just two masses of rock and ice meeting at speed and breaking apart into new pieces, each one now on a slightly different path than either of the originals. One of the fragments was more than 10 kilometers across. The collision had knocked it onto a diagonal, cutting across the orbits of the others, no longer moving with the belt's general current, now following a new line through space. Inside it, frozen permafrost on the surface, and deeper in, carbon, hydrogen, and oxygen, the same three elements that form the backbone of every living cell on Earth. Shift attention to space, soft and contemplative. Between Mars and Jupiter lies the asteroid belt, billions of rocks moving together like silent traffic. 320 million kilometers from Earth, two asteroids collided. One fragment, more than 10 kilometers across, was knocked onto a new path, diagonally cutting across the others. It began a journey that would last millions of years, silent and invisible. The fragment was made of rock and water, frozen permafrost on the outside, with carbon, hydrogen, and oxygen within. These are the same building blocks of life. Asteroids like this, one may have first seeded life on Earth billions of years before. What gives life can also take it away. The terrible fact about this asteroid is that it was not unusual. The belt between Mars and Jupiter contains billions of rocks just like it, colliding quietly and constantly, sending fragments spinning off in new directions all the time. Most miss, most have always missed. But this one, more than 10 kilometers across, found a path. A slow, patient, million-year path that led directly to Earth. It carried within it carbon, hydrogen, and oxygen, the same elements that built the first living cells on this planet billions of years before. Scientists believe rocks like this one may have originally seeded life on Earth, delivering the raw ingredients across the emptiness of space. Therefore, what was coming was built from the same stuff as everything it was about to destroy. The same elements that made the first bacteria, the first ocean, the first forest. Those same elements were now locked inside a rock, moving through the dark, aimed at ending 160 million years of animal life. What gives life can also take it. The asteroid proved both things true at once. There is one reason, one object that stands between Earth and the debris field that surrounds it. You can see it on any clear night without a telescope. Its surface is covered in the scars of every hit it absorbed, so Earth didn't have to, and some of those craters are wide enough to swallow a small country. For billions of years, it has been doing this quietly, with no acknowledgement, intercepting rocks that would have ended the story of life here before it had time to become complicated. But the moon cannot be everywhere. Its orbit is fixed, and the fragment that had been traveling through empty space for millions of years was now on a path that the moon's orbit would not cross. Not this time. Look up on any clear night and you can see it without a telescope. The moon, sitting in the same position it has occupied for 4.5 billion years, its surface pale and still and scarred. Every crater on that surface is a record of something that hit it instead of hitting Earth. The moon has been doing this work since before the first single-celled organism appeared in the ocean, absorbing, deflecting, taking impacts that would have reshaped this planet's history at every stage of life's development. The Tycho crater sits near the moon's southern hemisphere, more than 80 kilometers wide, its walls rising kilometers above the surrounding surface. The rock that carved it was roughly half the size of the one now on a new trajectory through the asteroid belt. The moon took that hit and kept moving, kept orbiting, kept doing the quiet work of standing between Earth and the debris field that surrounds it. Scientists estimate the moon intercepts thousands of objects over geological timescales that would otherwise have reached Earth's atmosphere. The math is straightforward. Without the moon, the history of life on this planet would look completely different. The moon has been the reason life here had time to become complex, to become large, to become the world of towering animals eating a ton of leaves a day and ruling continents for 160 million years. A peaceful detour about the moon. Perfect sleep imagery. The moon has protected Earth for billions of years. Its surface is pockmarked with the scars of countless collisions. The Tycho crater is more than 80 kilometers wide, formed by a rock only half the size of the one now approaching Earth. But the moon is rarely in the right place at the right time. Nothing would stop the asteroid this time. Therefore, the moon's failure to stop this particular rock is not a flaw in some cosmic system. It's just probability. The moon has absorbed thousands of hits that would have ended life on Earth, its surface scarred into craters that tell the story of every near miss this planet never had to survive. The Tycho crater alone, more than 80 kilometers wide, was carved by a rock roughly half the size of the one now cutting silently across space toward Earth. The moon took that hit, so Earth didn't have to. But the moon cannot be everywhere. It cannot intercept every fragment that escapes the belt. And this one was already past the point where anything in our solar system could have redirected it. Therefore, everything that happened next was not fate and not accident. It was just a number that had finally come up. The Guardian was there. It simply wasn't in the right place on the right day, and that was enough. The asteroid was close now. Close, in cosmic terms, means days. And on the last day before everything changed, the planet below had no idea. Not a single animal, not a single plant, not a single organism anywhere on Earth had any mechanism for detecting what was about to happen. Because nothing in 66 million years of continuous life had ever needed one. The Alamosaurus mother pressed her eggs into the soil that evening the same way every Alamosaurus mother before her had. The Coronosaurus herds walked to the water as they always had. A meteor shower lit the sky, harmless, brief, and already carrying something inside it that none of the animals awake to see it could have understood. This was the last ordinary night on Earth, and nothing alive knew it. 66 million years ago, on what was, by every measure available to the animals living through it, an ordinary evening. Life on Earth was doing what it had done every evening for longer than most species had existed. In Mongolia, Coronosaurus herds made their way to watering holes in the late afternoon light. The same route, the same water, the same behavior repeated across countless generations without variation. On the plains of what is now Mexico, an Alamosaurus mother was choosing her nest site, pressing her eggs into warm soil in groups of 5 or 6. The same careful instinct she had inherited from every Alamosaurus mother before her, all the way back through a lineage so old that the mountains visible from where she stood hadn't existed yet. Under normal conditions, only 1 in 3,000 of those eggs would survive long enough to reach adulthood. She had no way of knowing that these conditions were about to stop being normal. In British Columbia, Quetzalcoatlus pairs roosted on cliff edges above the coast, their enormous wings folded, the sea below them dark and flat. That night, a meteor shower lit the sky, fragments burning up in the upper atmosphere, brief white scratches across the dark. Small mammals in the undergrowth looked up between foraging runs and saw the light, then went back to the soil. It was, by every sign available to anything alive, just another night. The calm before. Use sensory imagery. The world about to change without knowing. Across the planet, life carried on, as it had for 160 million years. In Mongolia, Coronosaurus herds gathered at watering holes. On the plains of what is now Mexico, an Alamosaurus mother prepared to lay her eggs, laying them in groups of 5 or 6 to improve their chances. Under normal conditions, only 1 in 3,000 would reach adulthood. In British Columbia, Quetzalcoatlus pairs roosted on cliff tops. That night, a meteor shower lit the sky. Small fragments burning up in the atmosphere, outriders of the much larger rock to come. It was the meek who witnessed it. The small mammals foraging in the dark. The birds stopped singing. The animals froze, as if the earth itself were holding its breath. Therefore, the most haunting detail of that final night is how completely normal it was. An Alamosaurus mother in what is now Mexico laid her eggs in groups of 5 or 6, the same way Alamosaurus mothers had been doing for millions of years, knowing instinctively, without knowing at all, that only 1 in 3,000 of her young would survive to adulthood. In Mongolia, Coronosaurus herds gathered at watering holes, as they always had. Quetzalcoatlus pairs roosted on cliffs above a sea that didn't yet know what was coming. The meteor shower that lit the sky that night, small fragments burning up in the atmosphere, harmless flashes across the dark, was simply the outriders of something too large to burn away. And the only creatures awake to see it were the small mammals in the undergrowth, noses pressed to the soil, too low to the ground to look up. Therefore, the last evening passed, the same as every other evening had for 160 million years. Nothing announced it. Nothing marked it. The world simply had no mechanism for knowing it was already over. There is a crater at the bottom of the Gulf of Mexico, 180 kilometers wide and 20 kilometers deep, that has been sitting there for 66 million years. It is the most consequential scar on this planet's surface, and it was formed in a fraction of a second. The asteroid that made it was traveling at up to 72,000 kilometers per hour when it entered the atmosphere, crossing the entire width of the Atlantic Ocean in 4 minutes. And when it hit the shallow limestone shelf of the Yucatan Peninsula, the energy it released was not just large. It was the largest single release of energy in the history of complex life on Earth, delivered at the worst possible angle into the worst possible geology, in a way that every physical variable made worse simultaneously. The asteroid entered Earth's gravitational field, and the planet's pull did what gravity always does. It accelerated. What had been moving at tens of thousands of kilometers per hour was now moving faster, pulled downward along a shallow 30-degree angle toward the surface of the Gulf of Mexico. Friction began immediately. The atmosphere, which normally acts as a brake for smaller objects, had almost no effect on something this size, 10 kilometers across, dense, carrying momentum that had been building across millions of years of travel through empty space. The air compressed ahead of it faster than sound could move through it, heating to 20,000 degrees. Brighter than the surface of the sun, a light visible from the ground for a radius that covered the width of continents. The asteroid was not slowing down. It crossed the entire width of the Atlantic Ocean in 4 minutes. Everything beneath it, the shallow coastal water of the Yucatan Peninsula, the soft limestone seafloor, the miles of ocean sitting above it, was about to receive 100 million megatons of energy at a single point, delivered faster than any natural process on Earth had ever moved before. The pivotal moment. Render with awe, not panic. Slow narration, scale-based facts. The asteroid entered Earth's gravity and accelerated to between 65,000 and 72,000 kilometers per hour. It crossed the Atlantic in just 4 minutes. Friction turned it into a fireball. The surrounding air superheated to 20,000 degrees, burning brighter than 1,000,000 suns. It struck the shallow waters of the Gulf of Mexico on the Yucatan Peninsula at a shallow 30-degree angle. The impact released 100 million megatons of energy. The asteroid disintegrated completely. The entire ocean at the impact point vaporized in a fraction of a second. 120,000 cubic kilometers of Earth's crust exploded upward. The crater left behind was over 180 kilometers wide and 20 kilometers deep. The Chicxulub crater still buried beneath the Gulf today. Therefore, the scale of the impact is best understood not through numbers, but through what the numbers mean. 100 million megatons of energy, that is not something the human brain can picture. But consider this: the largest nuclear weapon ever detonated by humans released 50 megatons. The asteroid released 2 million times more than that in a single second. It entered the atmosphere moving between 65 and 72,000 kilometers per hour, crossed the entire Atlantic in 4 minutes, and compressed the air ahead of it so violently that the surrounding atmosphere heated to 20,000 degrees, hotter than the surface of the sun. The shallow waters of the Gulf of Mexico evaporated in a fraction of a second. The ocean simply wasn't there anymore. 120,000 cubic kilometers of Earth's crust exploded upward, and the crater left behind, the Chicxulub crater, still sitting beneath the Gulf today, was 180 kilometers wide and 20 kilometers deep. The asteroid itself was completely gone. It had given everything it had to a single point on the planet's surface, and that was more than enough to change the entire world. The impact itself lasted a fraction of a second. What it produced lasted much longer, not as one catastrophe, but as 4, each one distinct, each one traveling at a different speed through a different material, each one arriving at a different part of the planet at a different time and making the damage the previous wave had done significantly worse. The flash, the rain of stone, the earthquake, the blast wave. They did not arrive together. They built on each other, and the planet had no time between them to stabilize, no window where anything could begin to recover before the next wave arrived and reset the destruction to a new level. Within 5 minutes of the impact, entire ecosystems that had existed for tens of millions of years were simply gone. The moment of contact lasted a fraction of a second. What came after lasted much longer. The energy released at the Chicxulub impact site had to go somewhere, and it went everywhere, simultaneously in every direction the laws of physics allowed. An impact of this size does not produce one effect. It produces a cascade, each wave distinct, each one carrying a different form of destruction outward from the same central point, moving at different speeds through different materials, reaching different parts of the planet at different times. The flash moved at the speed of light and was everywhere at once. The rain of stone moved slower, following ballistic arcs through the upper atmosphere. The earthquake moved through the rock of the crust, constrained by the density of the material, but capable of traveling the entire circumference of the planet. The blast wave moved through the air itself, a pulse of compressed atmosphere expanding outward at supersonic speed, 800 kilometers from the impact site. The air temperature from the flash alone reached 300 degrees, hotter than the inside of a kitchen oven, sustained across a radius larger than most modern countries. Describe the cascade gently as a sequence of natural phenomena, not violence. The flash, a wave of light and heat, traveled outward. 800 kilometers from impact, the air reached over 300 degrees Celsius. The rain of stone, boulders the size of buildings, blasted skyward, fell back to Earth. The earthquake, a tremor measuring 11.1 in magnitude, nearly 60 times more powerful than any earthquake humans have experienced. The seismic waves rang the planet like a bell. The blast wave, a pulse of compressed air radiating outward at supersonic speed, circling the planet. Within the first 5 minutes, entire ecosystems near the impact had vanished. Therefore, what the impact did was not one catastrophe, it was 4, arriving in sequence, each one building on the last. The flash came first, a wave of heat traveling at the speed of light, raising temperatures 800 kilometers away to over 300 degrees. Then the rain of stone, boulders the size of buildings thrown into the upper atmosphere, and falling back as burning debris across thousands of kilometers. Then the earthquake, measuring 11.1, nearly 60 times more powerful than anything modern humanity has ever felt, sending seismic waves through the crust so forcefully that the planet rang like a struck bell, awakening volcanoes that had been dormant for centuries. Then the blast wave, a wall of compressed air moving at supersonic speed, circling the planet not once, but multiple times. Each wave arrived before the survivors of the last one had recovered. Therefore, within 5 minutes, ecosystems that had existed for tens of millions of years near the impact site were simply not there anymore. Not damaged, not disrupted, but erased as completely as if they had never been. The impact was over. The crater was formed. The rock had disintegrated completely, but the material it had blasted upward, 70 billion tons of pulverized earth, launched above the weather layer into the upper atmosphere, was only just beginning its work. This was not ash. It was not smoke. It was a ceiling being pulled across the planet, thinning as it spread, but never disappearing, trapping the heat of the burning forests below while blocking the sunlight that every living thing on the surface needed to survive. And it was moving fast, reaching British Columbia 16 minutes after impact, Mongolia in under an hour, covering the entire planet in a matter of days. The sky itself was the weapon now. The ejecta cloud was not smoke. It was not ash in the way a volcano produces ash. When 120,000 cubic kilometers of Earth's crust exploded upward, the material went high, past the weather layer, past the stratosphere, into the upper atmosphere where there is almost no wind to slow it and almost no gravity strong enough to pull it back quickly. 70 billion tons of pulverized rock hung above the planet, spread by the rotation of the Earth itself, thinning as it spread, but never disappearing. As individual fragments began their slow return through the atmosphere, friction heated them to 800 degrees, and the sky itself began to glow, not with sunlight, but with the heat of billions of pieces of rock re-entering simultaneously, turning the upper atmosphere into something closer to the inside of a furnace than the inside of a sky. 16 minutes and 40 seconds after impact, seismic waves reached British Columbia 5,000 kilometers away. By 44 minutes, the ejecta cloud had reached Mongolia. Ground temperatures in the worst affected regions climbed to 150 degrees. Static electricity built up inside the cloud as particles collided with each other, generating lightning across a sky that was already raining superheated rock. Slower pacing again, global, atmospheric scale, 70 billion tons of pulverized stone and dust were thrown into the upper atmosphere, the ejecta cloud. As fragments re-entered the atmosphere, friction heated them to 800 degrees Celsius. 16 minutes and 40 seconds after impact, seismic waves reached British Columbia, 5,000 kilometers away. About 44 minutes after impact, the ejecta cloud reached Mongolia, 12,000 kilometers away. Ground temperatures peaked at 150 degrees Celsius in some regions. The ejecta cloud carried electrical storms. Millions of volts of static charge created lightning, and superheated rocks fell as burning hail. Across North America, forest fires ignited, firestorms generating their own winds, walls of flame reaching 1,000 degrees Celsius. Therefore, the part of the impact that killed things farthest from the strike point was not the explosion itself, it was the sky. 70 billion tons of pulverized rock and dust were thrown into the upper atmosphere, and as those fragments re-entered, friction heated them to 800 degrees. 16 minutes and 40 seconds after impact, seismic waves reached British Columbia, 5,000 kilometers away. 44 minutes after impact, the ejecta cloud had reached Mongolia, 12,000 kilometers from the strike point. Ground temperatures in some regions peaked at 150 degrees. The ejecta cloud carried its own electrical storms, static charge generated by billions of superheated particles, creating lightning across a sky that was also raining burning rock. Across North America, forest fires ignited into firestorms, walls of flame that generated their own wind systems and reached temperatures of 1,000 degrees. Therefore, what burned that day was not just forest. It was the oxygen supply, the food supply, and the insulating layer of atmosphere that every living thing on land depended on to stay alive. The land was burning, the sky had closed over, and the ocean, the one place that seemed, from a distance, like it might offer some protection from what was happening above the surface, was doing something that the animals on the coastlines had never seen before and had no instinct to respond to. The seafloor beneath the Gulf of Mexico had collapsed. The ocean pulled back from the coasts, exposing miles of raw seabed, retreating in a withdrawal that happened in minutes. The animals still alive on those coastlines, having survived the heat and the falling rock and the earthquake, now stood in open air above bare seabed, in silence, in a pause that lasted just long enough for what came next to build its full momentum before it turned back toward the land. The seafloor beneath the Gulf of Mexico at the moment of impact was limestone, soft, sedimentary rock that had been built up over millions of years from the compressed remains of marine organisms. When the asteroid hit, the shock wave traveled downward through the water column and into that rock at speeds the material had no way to absorb. Sedimentary layers that had been stable for millions of years collapsed inward. The seafloor, designed by slow geological time to hold steady, was suddenly moving. Water responds to displacement from below the same way it always does. The surface moves. The ocean pulled back from coastlines around the Gulf first, dragging backward in a withdrawal that exposed miles of raw seabed, the kind of retreat that in any other context might look like a tide going out, except happening in minutes instead of hours. Animals on those coastlines that had survived the flash and the falling rock now stood on exposed seafloor, in air that was already superheated, in a silence that preceded something much larger than anything that had hit the coast so far. The water that had pulled back was gathering, walls of it up to 100 meters tall, building momentum across the open ocean before turning back toward the land. Quieter again, almost mournful. The impact sent shock waves through the seafloor, collapsing sedimentary rock hundreds of meters down. The ocean was first dragged back from the coast, exposing miles of seabed. Then came the mega tsunamis, walls of water up to 100 meters tall. They struck more than 20,000 kilometers of coastline. Entire shorelines simply washed away into the sea. Therefore, even the coastlines, the places farthest from the fires, pressed against the cooling edge of the ocean, could not escape. The shock waves from the impact traveled through the seafloor, collapsing sedimentary rock hundreds of meters below the surface, and the ocean responded the only way water knows how to respond. It moved. First, it pulled back from shore, retreating miles inland in reverse, exposing raw seabed that hadn't seen open air in millions of years. Then it came back. Walls of water up to 100 meters tall, taller than most modern skyscrapers, struck more than 20,000 kilometers of coastline. The shorelines of what would become North America, South America, and Europe were rewritten in a matter of hours. Entire coastal ecosystems that had never faced fire or falling rock found themselves simply washed into the sea. Therefore, there was no geography left on Earth that had not been touched. Not the high ground, not the deep coast, not the forest interior. The planet had been reached everywhere at once. The worst part of what the asteroid did was not the impact. It was not the fire, or the earthquake, or the tsunamis. The worst part was what came after all of those things ended. When the immediate destruction had finished, and the planet was left in the dark, cooling, silent, with no sunlight reaching the surface and no sign of when it would return. The dinosaurs that had survived the first day were not safe. Nothing that needed food was safe. And the food chain, every food chain, on every continent, in every ocean, had just had its foundation removed. What followed was not a second disaster. It was the same disaster, continuing in slow time, species by species, in a silence that lasted not days, but thousands of years. Within hours of the impact, the planet's sky was gone. Not the sky itself, but the light inside it. Dust and smoke from the burning forests, ash from the volcanoes shaken awake by the seismic shock, and the ejecta cloud still distributing itself through the upper atmosphere, combined into a layer thick enough to stop sunlight from reaching the surface. Not dim the sunlight, stop it. The planet below the cloud was in a darkness more complete than any night, because at night, light still filters through from stars, from the moon, from the diffuse glow of an atmosphere that carries ambient light in every direction. Under the ejecta cloud, none of that reached the surface. Temperatures began to drop. The forests that hadn't burned were now sitting in cold and dark, and the biochemical process that turns sunlight into energy, the process every plant on Earth depends on, had no sunlight to work with. Photosynthesis needs light the way a fire needs oxygen. Remove it, and the process simply stops. Every leaf still attached to every tree that had survived the fires was now just waiting in the cold and the dark for light that was not coming. The dormant volcanoes awakened by the earthquake were adding their own contribution. Sulfur dioxide and carbon dioxide pouring into an atmosphere that was already sealed from above. The slow heart of the documentary, where listeners drift into sleep. Within hours, the entire planet was covered in dust and smoke. The seismic shock awoke dormant volcanoes around the world, adding more ash and toxic gas to the atmosphere. Sunlight could no longer reach the surface. A nuclear winter began. Temperatures plummeted. Photosynthesis stopped. Plants died first, then the herbivores that fed on them, then the carnivores that fed on the herbivores. The huge Alamosaurus, which once needed a ton of leaves a day, found nothing growing. In low-lying basins, hydrogen sulfide gas released by volcanic activity collected invisibly, paralyzing the lungs of any animal that came to drink. Even in the seas, algae died, food chains collapsed, and the great marine reptiles followed the dinosaurs into silence. This was not a death in a single day, but in slow, merciless time, each species taking a last step, a last breath, a last look. Therefore, what followed the impact was in many ways worse than the impact itself, because it was slow. Within hours, the planet was wrapped in a layer of dust and smoke so thick that sunlight could no longer reach the surface. The seismic shock had awakened dormant volcanoes around the world, and they added their own ash and toxic gas to an atmosphere already poisoned and dark. Photosynthesis stopped. Not slowed, stopped. Plants, which had been the foundation of every food chain on land, began to die first. Then the herbivores that depended on them. Then the carnivores that depended on the herbivores. The Alamosaurus, which once needed a ton of leaves every day just to maintain its body weight, wandered a planet that was no longer producing a single leaf, and an animal that size cannot wait. In low-lying basins, hydrogen sulfide released by volcanic activity settled invisibly above watering holes, paralyzing the lungs of anything that came to drink. Even in the oceans, algae died, food chains collapsed from the bottom up, and the great marine reptiles followed everything else into silence. Therefore, this was not a death that happened in a day. It happened in slow, merciless time, each species taking a last step somewhere, a last breath somewhere, disappearing without any awareness that it was the last of its kind. 75% of all species on Earth were gone by the time the sky cleared, but 25% were not. Something survived, not because it was strong, not because it had seen the asteroid coming, not because it had any advantage that would have meant anything in the world that existed before the impact. The animals that made it through were the ones that had spent millions of years being pushed into the margins of a world that had no room for them anywhere else. Small, hidden, flexible, living underground or underwater, eating almost anything, needing almost nothing. The extinction did not spare the best. It spared the most accidentally suited. And the difference between the ones that made it and the ones that didn't was narrower than it should have been. Survival at the level of a species is a numbers problem. Any species can absorb losses. That's what reproduction is for, what genetic variation is for, what the instinct to flee danger is for. A healthy population can lose thousands of individuals and still carry enough genetic material, enough breeding pairs, enough geographic spread across different habitats to rebuild. The question the asteroid posed to every species on Earth was not, can you survive today? It was, do you have enough individuals left, spread across enough different places, eating enough different things, to keep the population above the line where recovery is still possible? Many dinosaur species had already crossed that line, while individuals were still walking. The last T-Rex alive on Earth died alone, somewhere, with no others left to replace it, and by that point, its species was already finished, had been finished for longer than it knew. But in the soil beneath those last footprints, other animals were still moving. Small mammals burrowed into the earth, insulated from the temperature swings above by meters of soil. Fish held steady by the thermal mass of deep water. Seeds pressed into cold ground, carrying the genetic instructions for entire forests inside casings the size of a fingernail, waiting for conditions that could still return. A gentle, hopeful turn. To survive any species needs to maintain a critical mass of population. Many dinosaurs were still walking even as their species were already finished. But beneath the surface, life persisted. Small mammals like Madma scampered into burrows, sheltered from the worst the asteroid could throw at them. Fish were protected beneath the water. Birds, especially waterfowl, survived by diving underwater or hiding in burrows. Insects, amphibians, and seeds buried in cool soil endured. The earth would be inherited by animals that were good at hiding. Therefore, survival in that world had almost nothing to do with strength. The animals that made it through were the ones whose lives had already been built around scarcity, darkness, and hiding. Small mammals like magma pressed into burrows beneath the surface, insulated from temperature swings that would have killed anything standing in the open air. Fish were protected by the thermal mass of the water above them. Birds, particularly waterfowl, could dive below the surface or shelter underground. Insects, amphibians, and seeds buried deep in cool soil simply waited. The planet would be inherited by animals that were good at disappearing, and those animals had been practicing disappearing for millions of years, right under the feet of the creatures that never had to. Therefore, the extinction did not simply remove the biggest things and leave the rest. It selected, precisely and without mercy, for every trait that the age of dinosaurs had made unnecessary: smallness, flexibility, the ability to eat almost anything, and the willingness to live in the dark. The skies cleared. Not quickly, it took thousands of years, but they cleared. And when the light came back, it came back to a planet that had been stripped to its foundations. Bare soil, cold water, the chemical remains of everything that had burned or frozen or starved. What grew first was the simplest thing that could grow. What came after that was the beginning of a process that would take millions of years to produce anything recognizable as the world you know. And at the end of that process, 66 million years after that one rock hit, that one shelf of limestone, on that one afternoon, one branch of the animals that had hidden in the dark long enough to survive would come down from the trees, stand upright, and eventually begin asking what had happened. The skies did not clear in a year. The process of an atmosphere rebuilding itself after an event of this scale is not a quick one. The ejecta particles were fine enough to stay suspended for months, and the volcanic activity triggered by the seismic shock continued adding material to the upper atmosphere long after the initial cloud began to settle. It would take thousands of years for the light to fully return to the surface, and the planet that waited for it was not the same planet that had lost it. The forests were gone, burned, frozen, starved of light, stripped down to bare soil and rock in most regions of the world. The animals that had once moved through those forests in their tens of millions were, with only a handful of exceptions, gone with them. What was left was a planet with soil still intact, with water still in the oceans, with seeds still buried, with small, warm-blooded animals still pressed into burrows, waiting for conditions they could handle. The first things to grow were the things that needed the least: mold and fungus spreading across the debris fields, feeding on the dead material piling up on every surface, asking nothing from the sun because they had never needed it. Then, very slowly, the ferns came back. The closing, peaceful, resolves the journey. It would take thousands of years for the skies to fully clear. The first life to thrive was simple: mold and fungus, feeding on what had fallen. Then came ferns, tough, resilient, carpeting the planet in green. Thousands of years later, ferns gave way to forests, and oxygen filled the air again. The mammals, once hidden in shadow, multiplied and diversified. 10,000 species spreading across the planet. Eventually, one branch of them came down from the trees, walked on 2 legs, and grew bigger brains. The dinosaurs ruled the Earth for 160 million years. Humans have ruled it for only a fraction of that. Yet, we exist only because that one rock, on that one day, changed everything. It was not the end of life. It was only the beginning of us. Every mountain, every fossil, every ancient stone carries the memory of that day. The day the Earth stopped and slowly, quietly began again. Therefore, What rose from that planet was not a recovery in the way we usually mean the word. It was something stranger. The first life to spread across the ruined surface was mold and fungus, organisms that fed on decay, that needed nothing from the sun, that required only the dead material piling up around them. Then came ferns, tough and ancient and nearly impossible to kill, carpeting a planet that had been stripped of everything else. Thousands of years after that, forests returned, and oxygen filled the air in concentrations that could sustain larger, more complex animals. The mammals that had survived by hiding multiplied into 10,000 species across every continent. One branch of them eventually came down from the trees, stood upright, and began to grow the kind of brain that would, one day, look up at the sky and wonder what had caused all of this. The dinosaurs had ruled the Earth for 160 million years. Everything humanity has ever built, every civilization, every city, every record of our existence, all of it fits inside a fraction of that time. Therefore, we are not the natural conclusion of life on Earth. We are an accident, a consequence of one rock, on one specific angle, hitting one specific shallow shelf of ocean, on one specific afternoon. And everything we are came from the silence that followed. Every fossil in the ground, every ancient stone in every mountain carries the record of that day. The day the Earth absorbed the worst thing the solar system had ever thrown at it, and slowly, without permission, without any plan at all, began again.